right, so the idea of these transaminase reactions, these are the ones that, right, they're transamination, so they are moving an amine group from one place to another. And all of these transaminases, there's one unique for every single amino acid as well as lots of other ones. Okay? Their goal is always to start off with one amino acid and one alpha keto acid. Okay? So the amino acid you should be able to recognize. It's right. So here is our carboxylate. Here's the amino group. That's a traditional amino acid. An alpha keto acid is one where you have on the alpha position, right? So alpha to your carboxylic acid, you have a ketone, alpha keto. Okay, so the name makes sense. So we start off with one amino acid, one alpha keto acid, and in this example, I'm showing pyruvate. And the reaction basically switches those two functional groups. What we see here is on our original amino acid where we had this amine, it becomes the ketone. So our amino acid becomes an alpha keto acid. Our original alpha keto acid became the amino acid. So we are transferring the amino group from one molecule to another molecule, hence the transaminations. Okay? The way this kind of happens is it has to be catalyzed by an enzyme that will hold on to an amine. Okay, and the reason for this is if you were thinking about this kind of just kind of like happening in the environment, it would have to go through this process where a free amine is produced, right? So down here we start off with, so up here we have our the amino acid we start with would have to then break this bond, giving up its amine while it's reacting with water to make the alpha keto acid, right? So we would generate this ammonia molecule. And that ammonia molecule could then react with the alpha keto position of the other substrate to produce the amino acid. But this is not favorable. It's not a good thing. And the reason it's really not ideal is because generating this ammonia can be really toxic, right? Remember that the big point, one big massive point of like having all of these things floating around the cytoplasm is to make sure that conditions are buffered. If we have a massive production of amine, that's definitely going to impact the pH of any cell. That's one problem. Another thing is it's simply fairly reactive, and we don't want a fairly reactive thing floating around to react with whatever the heck it wants, right? So instead of generating this free amine or evolving ammonia, instead what we do is we create a situation where we can create a covalent intermediate where that amine is held on to our cofactor. And this is where our cofactor PLP comes in. So pyridoxal phosphate, this is one of the vitamins that you get in your diet or you take. The idea is pretty simple, is at this position right here, we can have an amine, an ammonia molecule attached, or we can have anything else that contains an amine attached. And what we're going to see is that we do this by reacting the amino acid with this position and then transferring that amine to another amino acid. Okay? So with that, I am out of time and we will pick up there